All right, so funny story, and since Jeremiah's not here, I'll go ahead and tell it. Jeremiah, I hope you watch this video and see, or at least hear your story. So I was talking to Jeremiah's mom last night at PTSA. I don't use first and last names together on the videos, but not that Jeremiah. I'm positive. So, his mom was like, so it was the funniest thing the other night. Jeremiah was doing his homework, and like I knew he was doing his homework, and then all of a sudden, he's on the phone. And I'm like, what are you doing? And he just gave me the whole like, okay, give me a minute, sort of like, so I like walked away and left him. And then I came back and said, who were you on the phone with? He said, well, I texted my teacher, and then he called me. So I was on the phone with my teacher. Please, if you guys are struggling on the homework, text me, and then that's opening the door for me to call you. Because if you text me about a problem, that lets me figure out what was the problem, how can I help you, and then once I'm ready, I can turn around and call you and get you taken care of. So, especially, even if it's not just homework, if you're working on a progression to mastery at home, and you have an issue, call me, text me, whatever. But I need like time to prep and make sure that I'm not like out taking out the trash or something else like that. So, I'm going to give these to everybody. If you then don't need one, just give it back. At like the end of class, just bring it back up or whatever. What? If you don't need one, because I'm just giving them to everyone, so nobody knows what grades people got. Later, if you don't need one of these, just give it back to me, so that it's not wasted. Don't throw it away. But if you mastered that test, or exemplary, if you mastered or exemplary that test, you do not need one of these, really. Read the first line right beside the hole punch. Who would like to read out loud this morning? Might as well have one of you. Don, go ahead. Nice radio voice.
Make sure that you turn in the original mastery with your corrections stapled to the back of the paper.
I like your emphasis. So, exactly what you just got back, your correction, your original test with your corrections, if I was you, at the end of class, I'd staple these all together. Go ahead right now, connect them all together. Yeah, because that needs turned in with your corrections and stuff. So, can I borrow? If I was Julian, if I needed to do corrections, I would take my test, my new progression mastery, put it on top of everything. As I'm working through this, if I hit a problem that I'm having issues with, then I go back and I look at my corrections and I figure out how do I solve that accurately, because all of these questions on the progressive mastery are exactly the same as what was on the original mastery.
What if you have already mastered?
Yes. Thank you for telling the whole class things that I don't like to communicate. Please don't share your grades with each other. It is unnecessary. You don't need to do anything else. Notice that that assignment is progressing to mastery. If you are already mastered, which now that everybody knows, I'm going to take this back, you don't have to do an assignment to get to mastery because you're already there. You've already shown me that you know the concepts. So, I go to buy lunch. I'm a nice guy, right? I don't have lots of money, but sometimes I'm a nice guy. So I go to buy lunch for Cullen and Goldring and myself. And if a meal consists of 2 tacos and a drink, what will be the total amount of tacos and drinks that I bring back? So myself, Mrs. Cullinan, and Mrs. Goldring, 3 meals, right? And if each meal is 2 tacos and 1 drink, how do I know what I will have total when I bring back? Jeremiah?
Multiply how many tacos and how many drinks, or how many people there were.
Yeah, so this is what we call, anybody help me out? Evie? The distributive property. So when we distribute that multiplication, the 3 multiplies into this parentheses, but because this parentheses has 2 tacos and a drink, there's 3 times the 2 tacos and 3 times the 1 drink, so I end up with 6 tacos and 3 drinks. Does that make sense?
Yes.
Nice. Our learning target today, which is kind of the same as what you did with the sub, but I know we need to review some of that, is being able to fluently multiply and divide with rational values and understanding that powers are the way that we notate repeated multiplication. So, I need to know from you guys what we need to review from the 5-5 notes that you did on Tuesday with the sub. So go ahead and get out the 5-5 notes if you have not done so already. You guys know that if we ever don't finish notes, you're just going to need them out first thing the next class you come to. Why is that? Yeah, I don't know if it works that way.
And now you have to pay me instead of me paying you.
Mr. Hudson, my mom tried to give me a propane tank to bring on the bus to you, but I'm pretty sure that's illegal.
I can come pick it up from your house if you guys
She's
need it.
bringing it Friday.
Okay.
You know,
Because we're doing the cookout next Friday. Reminder, cookout next Friday. Alright, so, in the 5-5 notes, are you guys good on this key?
the whole second page.
Okay, I know. But I'm going to work through the first page and make sure we're good.
Lose your track.
We good, gentlemen? Anybody that was still talking? If you ask me, it kind of makes it seem like you already know that you were the one. Are we good here notating how we apply the distributive property? This should have ended up looking, and if you write down the details, it's -5 times 3. Then you bring down the operation, and you do the other multiplication, -5 times 2, which a lot of times we will use parentheses to clean this up. And then there's still that plus the -4. I'm off the writable screen. Did we have something like this? And we should have seen that this becomes -15 plus a -10 plus a -4. We're good. And so all together, this becomes -29. Any questions on that process? Are we good on that first example? Does anyone want to see that again? The sign is the dangerous part. So this 6 has to have the negative on the 6 both times it multiplies. Saul, were you here Tuesday? Because it's the notes that at the top say 5-5. If you weren't here, you don't have them. Were you here on Tuesday? The first day of school for this week, which was Tuesday.
No, I was here that day.
Okay, so where are your notes?
Yeah.
So that's an organizational issue.
No, I just got help organizing yesterday.
So where are your notes then?
I have no idea.
Okay, so that's an organizational issue. We can talk in circles if you want.
Weird.
If you can't find your notes, that's an organizational issue. Anybody else need another copy of the notes? We lost them in 2 days. So, the big thing with that 6 is that negative has to stay attached to it no matter where it goes. So, which one of these was right? The first, second, or third? Okay. The third one, because the -6 has to multiply into the part of the parentheses. So first, I multiply by the -1/2, then I multiply by the +1/3. So if you color code your notes, that would be good to color code there, because that 6 has to keep its negative on it for the whole time. You guys good on the got it? This is actually really easy because anytime we're multiplying by 10, what are we really doing when we multiply by 10? What's the easy way to think about it? Dom? Yeah, we shift the decimal. And actually that works for any power of 10. So 10 or 100 or 1,000 or 10,000, 100,000, all of those, however many zeros you have, you just shift the decimal. So this multiplication makes this -58. But then, this is the weird part. I would rather make this addition first. And if you're having any issues with distributing, I would try to make everything addition. Because then, this is addition of a negative. You understand? I went from minus a positive to addition of a negative. So now, I can say, well, there's addition between these. And then, what's my second distribution? What's a negative times a negative? Positive, right? So that gives me positive 62. And I end up with just 4. Any questions? I know we're just kind of going quick because we're reviewing this from the other day. What was crazy weird about this problem, Elena?
The second one, the answer was -40.
The second one, the answer is the same as what we start with. There are only 2 temperatures in the Fahrenheit and Celsius scales that are actually the same as each other. -40 is one of them. Because -40 degrees Fahrenheit, which is 72 degrees below freezing on the Fahrenheit scale, -40 on the Celsius scale is 40 degrees below freezing. But on the Celsius scale, remember those gaps are different amounts. They're different amounts of temperature. So I would maybe challenge you. There's another temperature that's identical. Curious if anyone can figure it out. Sorry, this was not negative 10. What was the top one? 14, my bad. All right, did you do this? Got it? Because this one I actually kind of goofed up when I wrote the notes to begin with, so then I had to put a Post-it over. Yeah, well, she had the right solution because the Post-it was there. But are you guys good on this?
No.
No? Okay, so this formula is different. If you compare the Fahrenheit formula to the Celsius formula, what is different about them? Honestly?
That's 9/5 and 5/9.
We have inverse fractions, I agree. But there's also something else different. Like, think about the order that we do things in, Julian.
F minus 52 instead of plus.
We have the Fahrenheit minus the 32 instead of adding 32. But what would I do up here first? What would I do in my Fahrenheit formula first? Andrew?
You would divide 9/5 or 9/5 or simplify.
Yeah, we would like do this multiplication, right? So we'd have to do 9/5 times whatever my Celsius is. What would we do first in the Fahrenheit formula?
You subtract 32.
Yeah, we have to do the parentheses first. So that's where it gets really weird. Here we multiply first. Here we have to do the parentheses first. Or your other option is you could distribute. So if we wanted to make another formula for Celsius, we could actually derive a new formula. Because if I distribute the 5/9, I could say that the Celsius temperature will be 5/9 times F. And you guys might as well show this distribution. This is a good example. And since this has the minus or the negative, I have a positive times the negative, or if I use it as a minus, either way, I know that this has to be minus or a negative. And then 5/9 of 32, that's really weird. And we'll talk about repeating decimals. 5/9 is a cool repeating decimal. Comes out to be 0.5 forever. So that's actually pretty sweet. The numerator repeats forever. But if we do 5/9 times 32, we get 17.7 forever. So that's where the problem comes in, is this subtraction would be minus 17 and 7/9. So this is why we don't distribute and have this different formula that is similar to the Fahrenheit, because this is too messy. We could do it, it's just messy. So instead, we just subtract first and then apply the 5/9. Jeremy? Yeah, as long as that number is less than 9. Yeah, it's like 8/9 is 0.8 forever. 6/9 is 0.6 forever. All right, so if we actually use this problem then, what is my temperature in Fahrenheit? On this thermometer, what's my temperature? Do we know how to read a thermometer? 5 degrees. Yeah, we're not even asked to read a thermometer here. It tells us. So plug it in. We have Celsius equals 5/9 of 5 minus 32. What is 5 minus 32? This is why we worked with positive and negatives. I can take that 5 minus 32 and change it to 5 plus a negative 32. Now I have addition, same sign or different sign? Different. So I need to. Yeah, so I know that the negative is greater, like bigger, more powerful. But what am I, because they're different signs, I need to find the difference. Guys, different signs, we find the difference. So 32 minus 5.
Negative 38.
Ooh. We're finding the difference between them, Evie, not adding them. They're different signs. That's a negative and that's a positive. They're competing with each other. They're going opposite directions. So it comes out to be negative 27. Why are you confused?
I got negative.
For your final answer? Yeah, this is not my final answer. This is just what was in the parentheses. So this, here we'll color code, came up to here and gave me this. So now we have Celsius equals 5/9 times the negative 27. Can I divide 27 by 9? Yeah. Then could I multiply that value by 5? When you have a fraction that you're trying to multiply with, it's doing two different things. It's multiplying by whatever's on top, and it's dividing by whatever's on bottom, and you can really do it in whatever order you want. Sorry? So 5/9 is saying multiply by 5, but then divide it by 9. Because really, I could write this as 5 times the negative 27 divided by 9. I could rewrite that a few different ways. I could make it negative 27 divided by 9, then times 5. It doesn't matter because order of operations, multiplication, division happen at the same time. And if I have 3 times 2 gives me 6, divided by 2 gives me 3. As opposed to 3 divided by 2 gives me 1.5, times 2 gives me 3. I can flip around the order. Because remember, multiplication and division are essentially the same thing. So, I think this is easier, and if you were trying to solve this without a calculator, forget about the negative for a second, because I know, will my answer here be negative or positive? Negative, because I'm multiplying with one negative. What's 27 divided by 9? 3 times 5. 15. And that's the same as if you took your fraction, 5/9, and then multiplied by your 27. Oh, did not catch all my typings. $15. Negative. Questions on any of the front before we shift to the back, which I don't think you guys did any of the back yet. So, complex fractions. What do you mean, oh my gosh? What do you mean, so why do you have that immediate reaction? I'm just curious, Sam. This is not that difficult. What is difficult about it is identifying which bar is which. And that is the dangerous part. So, notice how this bar is narrower than that bar. And you might even notate that this is a negative. That is not part of that bar. It's a negative. So I don't know how well your print came out, how well your notes printed out. But so we have negative 3/4 over 10. So wait, I have a fraction in a fraction. Is there a way that I could rewrite this? Because this is really messy. Negative 3/4 tenths. If I were to read this, negative 3/4 tenths. Right? Because if this is the main fraction bar, we're talking about tenths. How many tenths? Well, negative 3/4 tenths. What? What the crap are we talking about here? Dom, what can I do?
Okay, this is a guess, but I'm thinking, would you have to find a common denominator between all three of them?
I don't even have, well, I kind of have two denominators, but this denominator is part of my numerator.
So, wait.
What? Hold up. What is a fraction? Like, when you say 3/4, what's another way you could say 3/4? Ellie?
0.75.
Okay, but not as a decimal. You're right. It's funny when you guys are right, but it's not at all what I was thinking. So you're absolutely right. But what's another way we could use the 3 and the 4? So don't convert it, which is great. You already know how to convert it. What's another way we could talk about what does the fraction bar do, Elena?
Divides them.
It's division. So this, draw an arrow to that main fraction bar, is division. So all this really is negative 3/4 divided by 10. They just decided to stack it and make it all complicated.
Wow. They're so like missing
They're evil.
So here, then, is the really easy part. Can I make 10 into a fraction?
Yes.
Yeah, it's a rational number, right? What do? I put it over 1. Now, we don't like division. Ever since you've probably been taught long division, you learned that you don't like it. Okay, well,
Oh yeah, I like long.
I said that to the wrong class. Hey, bring it back. Bring it back. How can I not divide this? Ooh, lots of hands. Jaslyn.
So you keep the first one the same, and then you change the division sign to multiplication sign, and then you flip the denominator with the numerator.
From, I think, was it lesson 5-4? 5-3, 5-4, somewhere around there. We talked about keep, change, flip.
Keep, change, flip.
So I can take my negative 3/4. Guys, stop with the extraneous conversations. You've already told me that the 4 of you need broken up when I make the seating chart. So just so you're aware, that's happening. Negative 3/4, I change my division to multiplication. And then I flip my second fraction because dividing by 10 is the same thing as multiplying by a tenth. If I say, hey, take that pizza and divide it in 10, or divide it by 10, I guess to say correctly, that's the same as making 10 slices, and each of those slices would be a tenth. So you really just multiplied that pizza by a tenth. No, cross multiplication is only used for proportions. We never cross multiply unless there's an equals and a fraction on both sides. I don't know where, I know that cross multiplication happened in elementary school, but you start to think every time there are two fractions we cross multiply. Not at all. So, now we multiply straight across. Is my answer going to be positive or negative?
Negative.
Negative. How do you know that, Acadia?
Because the 3/4 is bigger than the 1/10.
That is not why. That would be if we were adding.
Oh.
You want to go again?
It's because you multiply by a negative.
I have one negative involved in my multiplication. One negative. So it makes my answer negative. 3 times 1 across the top gives me 3. 4 times 10 across the bottom gives me 40. I look for common factors that they could be divided by. 3 only has 1, 2, and 3, and 40, or sorry, not 2. 3 only has 1 and 3. 40 has a lot, but it doesn't have 3. And dividing by 1 does nothing, so we're done.
Well, dividing by 1 is just...
It does nothing. Anish? Okay, you're not actually cross-multiplying. Understand that you are doing a process that you're not allowed to do. Yes, you can stumble onto the right answer, but that's not the process to take. So, would you please trust me, you should not be doing that. Keep, change, flip. So, because you've now taken us down that rabbit hole, what Anish thinks he's doing, which is not correct. It's every 7th grade year, people think that we cross multiply here. What Anish is doing is actually here doing that, and here doing that. But the problem is the yellow becomes your numerator, and the green becomes your denominator, and that's not actually how this process works. So what you're doing is a manipulation of the fact that multiplication is the inverse of division, which we apply by inverting the fraction, but you're using an inverse process. It's just not good. So please trust me, we don't want to cross multiply. We want to keep, change, flip.
Last year we did this. We did the keep, change, flip.
Yeah.
We did keep, change.
And if you remember it that way, that's fine. I just like 3 different letters so that you know that they're different things. So, I want you to try to set up this problem on your own. Curious if you can do it. I want you to try to set this up, set up and solve it. So again, you want to make it just a fraction divided by a fraction. Yes, definitely. Improper does not make it not a fraction. I am a much bigger fan of improper fractions than I am mixed numbers. So, now our numerator is just like a integer, and our denominator is like that messy fraction part. So we're going to take that first, and we're going to say negative 3, then do the division by 2.5. And then you can make my 2.5 into an improper. So because this is negative 3 divided by 2.5, that's the first thing we write is just negative 3 divided by 2.5. Then I'm going to make this improper. Then I can apply KCF, and then I can actually solve it. Did you hear anything that I just said? Okay. So let's just bring it back together. This will be. What's the groan about? Do you know how to do it? Were you trying to like give a solution, or were you trying to ask a question?
I was trying to ask if I was correct.
Okay, so, well, I'll verify that here in a second. This, again, when we look at this and when we think about reading this, you just need to think about divided by. So, how that reads is negative 3 divided by 2.5. 2.5. And is between the whole and the partial. So, what's the first thing you did, Jeremiah?
I made the 2.5 a proper fraction.
Yeah, so you could. These first two steps are interchangeable. So I'm going to make it improper in my second step. The first thing I'm going to do is read this, and instead of writing it vertically, I'm going to write it horizontally. So I'm going to say this is really negative 3 divided by 2.5. Any questions on how I go from vertical setup to horizontal setup? Now I'm going to do Jeremiah's improper, which I could have done first, but this becomes negative 3 divided by 5/2. Even though I said it, I didn't even. You guys, as you get older, you start to lose your brain. Now, I don't like one fraction and one integer. So what could I do, Julian?
You can change the 3 to 3 over 1.
Yeah. Make it negative 3 over 1. And by the way, what's my answer going to be? Positive or negative?
Negative.
So somewhere, while you're thinking about that, put equals negative so you don't forget about it. Then we're going to apply our KCF. And that's going to give me negative 3 over 1 times 2 over 5. Any questions on anything I've done? What do you mean?
What are we solving?
So if water level was dropping 3 feet every 2.5 minutes, this answer is going to give me the unit rate of how much it changes every minute.
Oh.
So whenever you take 2 units and you divide them by each other, you're finding a unit rate. So if I did like miles per hour, and I had so many miles and so many hours, I do that division, I get how many miles you travel in 1 hour. This is going to tell me how much water in 1 minute.
Oh, okay.
So like if we were trying to drain a pool, we could then figure out how many minutes it would take. Because if you had like an electric pump going, you don't want the pump to run when there's no water. So you'd want to know, when do I need to come back here and turn the pump off? And if it's a gas one, it could actually burn itself up. Like, yeah, so not good. I multiply straight across the top, straight across the bottom. I don't need any more space to do my work. I get negative, because we got to remember that, 6 over 5. I'll go ahead and make that green just to match. Any reduction available, Evie?
It's 1 1/5.
Yeah, I can leave it like this, or I can make it mixed again and be 1 1/5. And regardless of which of these is my answer, that is feet per minute. Per 1 minute. So that water's dropping by 1 1/5 of a foot every minute. So after 10 minutes, it will have dropped 10.5 feet. Well, think of a normal pool. If we were draining water out of a pool, that'd be crazy fast to drain a pool. So this must be some industrial pump. Yeah, we're not going to go down that one today, the new iPhone. Do this on your own. If you're having any issues, please stick up a hand so I can help you. So you have to do this. Yeah, before you can like change it out of this form, but you could actually rewrite this as negative 5, so it's divided by this in parentheses, and you still have to solve parentheses first. But we could group together my denominator using parentheses. That's what they're trying to show you here, is we can take this complex numerator and group it together, and then do the divide by 3. any fraction that has an operation happening, whether it's addition, subtraction, division, multiplication, in the numerator or denominator, is a complex fraction.
This is actually really easy.
Be careful using the word easy. Easy's relative.
It's not easy. It's not easy.
All right, Dom. What'd you do?
I think so. Because I did it. Okay, I said it was negative 5/6 divided by 15 seconds, perhaps.
Yeah, so you can say that, but what did you do?
Oh, well, I took negative 5/6 and then I keep change for.
But first you have to write it out horizontally.
That's what I did.
Well, yeah, but you didn't tell me that.
Oh, sorry.
I can't read your mind, not yet at least. Alright, so Dom says
I
then,
gotta read mine.
keep change flip.
Yeah.
The more I get to know you, the better I am at mind reading. So this becomes negative 5/6 times 2/15. What'd you get,
I
Dom?
got 10/90.
Close. Help him out.
Oh, negative 10/90.
Negative.
Sorry.
And you're not done.
I put negative at my end because I simplified it.
Okay, well what is it?
At negative 1/9.
Negative 1/9.
I put my negative at the end. I actually understand this. This is amazing.
Alright, last one. So, when we have addition or subtraction involved in a fraction, we can group that together before we set it out horizontally. So, if you highlight, I would suggest highlighting that this 2/4 in my numerator gets grouped into the parentheses, and my divided by 3, both the fraction bar and the 3, just then come after it. So remember, whether I use the fraction bar or I believe that's called like the quotient symbol, the line with the dots. So then my 2 plus 4 becomes 6 because I have to do the parentheses first. Then I divide by the 3 and I get my final answer. So I want you to try to set up the same thing for this last problem right here. So what you're going to want to do is group the operation in parentheses, write it out horizontally, solve what's in the parentheses, and then solve the problem. No, you don't need one. Honest people, keep looking at your paper. Cheaters, I'm going to go ahead and start this. And this is where, like, whoever's watching the video, this now is, like, covered up. So that's why, hopefully, through that camera, they can see it. Which actually, well, I won't be able to see it if they can see it. What do I get inside those parentheses when I do my 1/3 minus 1? Andrew? Negative 2/3. So then when we apply keep, change, flip, this becomes negative 3/2. Before you really try to do the math, think about what will my answer be, positive or negative? Positive, because we have 2 negatives. Count them, 2, or you can say a pair of negatives. That becomes positive. So I'm going to put a little plus even though it's not necessary. I go straight through, straight through. What'd you get, Anish? Yeah, so we can cross cancel, which is, you don't have to cross cancel. We'll do some activities with this, but what do you cross cancel here, Anish?
I cross cancel 3 and 2, so I got
Wait, the 3 and what?
6.
And 6. Yeah, be careful. I know why you said the 2, though. Well, but, so what are we dividing by? We're dividing by 3, since both of these are divisible by 3. So I could make this a 1, and this becomes a 2. That's why I was thinking you said the 2. If I didn't do that, and I'll write the cross-canceled answer in red, but if I didn't do that, we'd have gotten 15/12. If I do cross-cancel, I get 5/4. 15/12, both of these numbers can be divided by. What can 15 and 12 both be divided by? 3, right? So, if I divide by 3 here, we get 5/4. Sorry, somebody just said I still don't understand. What is it? Which 2? This? 1/3 minus 1. Well, 1/3 minus 1 can really be looked at. 1 is 3/3, right? Because if you have 3/3 of something, you have all of it. So if I take 3 away from 1, I end up at -2, and I still have thirds.
Oh, the red 2.
Where this? That was from cross-canceling.
Oh, I see.
When we cross-cancel, values that are cross from each other, like diagonal, if they can divide by the same thing, we can cross-cancel them. But we don't have to do that because we end up dividing by that number to reduce. So you don't have to cross-cancel. You can, though. Yeah, if you make it back into proper or mix, it'd be 1 1/4. So my advice would be to staple that progressing to mastery to your current assessment. But I have like 5 minutes left. I want to take any questions on the homework. And I got an email. Thank you very much to the student who emailed me. Was it 5152?
So, Mr. Hudson, I have a question.
Yeah.
So, in the end, this would be positive 1 and 1 reward.
Yes.
Okay.
These problems right here. So many people, including some parents, have been grappling with these problems and why we're getting the answers that we are. Now, when we talk about the order of operations, we know it's PEMDAS, right? Or GEMDAS, if you want to think of what I say. Grouping symbols, exponents, multiply, divide, add, subtract. What happens first up here? Monis?
You separate this is how I would do it. You separate the 5 to the power of 3 from the negative to the negative bit later.
Why?
Because it helps me focus on the 5 and to the power of 3 because you're doing that first. And the addition and subtraction happens last. And that's a negative.
A negative symbol, I love everything you said. A negative symbol that is not grouped with my number falls in the category of addition subtraction. My exponent, my power there of 3, falls in exponents. So what we have to do first is 5 cubed, which becomes 125. Then I apply the negative, which becomes negative 125. Now, what's funny about this one is that's the same as if you grouped the negative with the 5 and solved it. So actually, either way that you solved that, you got the right answer, hopefully. Now, 18 was a different story. And your parents will tell you you're wrong. They are the ones that are wrong. Because back when they were in school, they looked at this as a negative 10 being raised to the second power. That is not correct. And with the Common Core, we are putting a huge emphasis on what is the actual right way to do math. Which is not saying your parents were taught the wrong way, but they were taught ways that had little bitty gaps and misunderstandings. The order of operations tells me square your 10 first. What's 10 squared? 100. So this then becomes negative of 100, then plus 4. Your parents will try to tell you that this is a positive 100, but you need to inform them that negative is not grouped with my 10. The power happens first, then the if you want to really impress your parents, say the arithmetic operation, which means add or subtract. It's just the fancy way. It's arithmetic. So the arithmetic operation happens after the exponential. That'll blow they'll be like, what did they just? The arithmetic operation happens after the exponential. It's crazy. Like you could write that down. They'll probably pay you money for saying something like that. But now I get negative 100 plus 4 gives me negative 96. And I know I just gave you the answers so you don't have to like struggle through those again. But anticipate problems just like this on the mastery. This is me telling you. Apparently my body doesn't want me to tell you. There will be a problem identical to this on the mastery. Different numbers, but identical process. Any other big struggles from 5.1 or 5.2? Because we should have this homework done by now. So is anyone still struggling on any of these questions?
Negative plus negative is a positive, right?
No, a negative plus a negative makes a bigger negative. If you have debt and you add more debt, yeah, because minus a negative becomes plus a positive. But your answer will be determined by which one's more powerful. So there's no straight up rule for what it becomes. It's which one's more powerful.
Have we done 3 and 5?
What? I don't understand what you're saying. So here's what's up. Tomorrow we will be doing the 5, 6. I have a stapler here, sorry, and a stapler there. Why are...
Wait, that was...
So here's a stapler. We're trying to staple those together.
No, I don't. Wait.
Yeah, so not now. Read the directions on the top. You need to complete that before you give it back to me.
Oh, that picture.